Today we're going to a new type of function. We're going to go to something called the quadratic function. Now let's go back and think about what a function is. Remember, a function is like that function machine. So if you have this machine, you're going to take some value, which we call x, and you're going to plug it into the machine. And inside the machine is some sort of equation. And that x is going to be substituted in, and we're going to get a value that comes out of the machine, and that's called our y. So our functions can go on coordinate planes because they have an xy value with them. So in the past, we worked with linear functions. And so linear functions created our linear equations. So we had something that like y equals negative 3x plus 4. And we learned that we could read this like a code, and we know that this first number attached to the x, that's my slope. And if that slope is negative, that means that line is downward sloping. And if that slope is positive, we know that line is upward sloping. And then we saw that we had a number attached to it, and that was our y-intercept. It told us where that line was going to cross that y-axis. So here I can see I have my downward sloping line crossing the y-axis at 4, and I have my upward sloping line crossing the y-axis at 2. So those were our linear equations. Now they were called functions because we used the vertical line test. And if I do a vertical line going all the way through that linear equation line that was created, and if it only passes through one point, then I know it has to be a function with that. So we're doing something very similar today, but now we're looking at quadratic functions. And the only difference, it's the equation. In a linear function, our x was just a single x. In a quadratic function, our x is squared. That's how we know the difference between a linear equation and a quadratic equation. So if I take a look at the quadratic, it also has both an x and a y, and therefore it can go on a coordinate plane. And my x can be either a negative x or a positive x. And it again tells us the direction that this quadratic function is going to be facing on the coordinate plane. Now, the drawing of the function is entirely different than the linear. So the drawing of it, it's a curved symbol, and that curved symbol is called a parabola. So if my x is negative, my parabola is facing down. If my x is positive, my parabola is facing up. Now, the point where the curve is either at the top of the parabola or at the bottom of the parabola. If it's at the top, which it always is when it's a negative x, that means we call that the maximum. It's the maximum height of that curve. If the curve is at the bottom, that means it's got to be at the bottom part of a positive parabola. That means it's the lowest point of the curve. That's why we call it a minimum. Now we're going to do the baby steps or beginning steps of graphing these quadratic functions. And because they're a function, remember they could go into that function machine, and it means that that x pops in, it goes through the equation, and the y pops out. And that's exactly what we're going to do today. It's like we are the machines that are putting the number in and seeing what number pops out. So our baby step, always you can start off by using a t-table. And we know a t-table works because it has both x and y values which match up with my x-axis and my y-axis. And I choose the number that's going to go into the machine. I can choose any number I want. I tend to choose numbers very close to 0 or the origin. So just like with linear equations, I had some favorite numbers. In quadratic equations, I do too. And my favorite numbers are -2, -1, 0, 1, 2. Now notice I chose 5 points because I really want to be able to capture that whole curve, where it starts, where it bottoms out, and where it comes back up again. So 5 points, it's my general rule. We always do that. And I'll just always choose that. So what I do is I start to plug it into the equation. So it means I'm choosing -2 to pop into my machine. When it goes into the machine, it goes into the equation. And that equation means I'm going to take the -2, and then that -2 that I popped in has to be squared. So when I square it, a negative 2 times a negative 2 is 4. Now I can complete the equation, but I have to follow my order of operations. So a negative 2 times 4 is a negative 8. Then I can do my negative 8 minus 1, which is negative 9. That means when I popped my negative 2 into the machine, it went through that quadratic equation. What popped out was negative 9. Now that gives me an ordered pair, and we know every time we have an ordered pair, we can just graph it. So if I take that negative 2, negative 9, I'm going to put a dot right there, and that's my beginning point with that. So now I got to go find my next dot. So I'm going to go, and now I'm going to say, all right, I'm going to pop in negative 1 into the machine. So I'm going to push negative 1 in. It has to go through the same equation, and I'm going to see what pops out. So negative 1 goes in. I have to square that negative 1, which becomes a positive 1. Now I follow my order of operations in the equation. So I'm going to do negative 2 times 1, which is negative 2, and negative 2 minus 1 is negative 3. So when negative 1 went into the machine, what popped out of the machine was negative 3. There it becomes my second ordered pair, and I go and I graph that. So then I do the third one, and you just keep repeating the process. So now 0 goes into the machine. When I square 0, it's just 0. Negative 2 times 0 is 0. Minus 1, I get negative 1. There's my next ordered pair. I graph it. Now I put 1 into the machine. I square it. I multiply by negative 2. I get negative 2. I subtract 1. I get negative 3. There's my next ordered pair. 1, negative 3. I plot it. Now, we're expecting to have some common points because we know that they have to curve up and down. So when I'm looking at this, I'm starting to see some points that look the same. Now I can kind of guess probably what this last point is going to be because that's what's going to complete my curve. And the curve usually goes on both sides of that y-axis. So one of the points would be a negative and one of the points would be a positive for that. So you can start to anticipate some patterns that are happening. So I'm going to take my last point, I'm going to pop it into the machine, and my last point is 2. Goes through the equation, and we can see it going through the equation. So first I square it to get 4, then I multiply it by the negative 2 to get negative 8. I subtract 1, I get negative 9. So it followed the pattern exactly the way I was expecting the pattern to be, and I plot that last point. So my final part of this is I'm going to connect my points with that curve, and that creates that parabola. And when I see that parabola, I can see right here, right there is my maximum value. And I can see right here, that would be my maximum value. So that is a basic process that you can take any quadratic equation, which simply means that your x value is squared, and you can find those ordered pairs that will create that parabola and draw the picture that matches that. So many people don't realize how much math creates drawings and pictures. When we're looking at functions, that's exactly what the math does. So have fun with it today. It's a little cumbersome pushing everything in, but I know you'll do well.